Right now we have any generic triangle. There's nothing special about it. It has three sides. We have angles A, B, C, and the opposite of angle A is little a, opposite of angle B is little b, and opposite of capital C is little c. To review what we did last class, we dropped the altitude down, and we could say, what if I want to label this height? Which trig function deals with angle A, the height, and angle B? We'd have angle. This is the opposite side to the angle, and this is the hypotenuse since it'd be opposite the right angle. So that is sine. So we could say the sine of angle A equals h over b. And if we solve for h, we get h equals b sine A. Similarly, we could do the same thing with b. Sine of b equals h over a, so we get a sine of b. Now we did that one yesterday. Now let's take a look and see, what do we notice about this? These are the same heights. What does that mean? That means we could say that b sine of angle A equals little a sine of angle B, using a substitution. Now let's take this equation and divide both sides by little a, little b. What happens? The b's reduce there, and we're left with sine A over little a equals the sine of b over little b. And that's part of our law of sines. Did it matter anything about the labeling of this triangle? No, this is some generic triangle. We could repeat this, instead having C here and B, or C and A, or A and C. It doesn't really matter. So similarly, we could come up with one more piece here. I'm not going to do it right now, but I think you could figure it out. We have sine of an angle over its opposite side equals the sine of another angle over its opposite side. What's the third piece? It's going to be sine of, well, what angle is missing? C over its opposite side. And this is known as the law of sines. What is so nice about this triangle, or this law, is the fact that this works for any triangle. When we dealt with SOHCAHTOA only works for right triangles. But now we have this law. It says it doesn't matter what type of triangle it is. This law will work. And that is the law of sines.